Let's take a closer look at what thermal runaway is and how it's caused and how we deal with it. So as I mentioned, thermal runaway is a chain reaction. It starts when any one cell in a system reaches a certain temperature, known as the ignition temperature. When that happens, the battery not only begins to burn, but it begins to consume itself in a way that does not require oxygen. And so that means that even if the cell were thrown underwater, it would not be put out because it's actually consuming itself. One hallmark of thermal runaway is that hot gases that are flammable are emitted. And the real danger of thermal runaway is that because the cell is so hot, that fire can quickly spread to other cells or other parts of the system, resulting in a chain reaction that can consume big parts of the system very quickly. So obviously something we want to avoid. If we take a closer look at a graph of a test being performed for thermal runaway, we see here that the test, after about 500 seconds, so just under 10 minutes, the test would see the cell go into thermal runaway, where we saw initially the temperature would gradually rise. We see that all of a sudden it jumps way up, gets up to almost 800 degrees Celsius, and then it gradually levels off. That's because the thermal runaway has consumed the entire cell in that period. We see that that onset temperature, or the ignition temperature where it happened, in this case was around 260 degrees Celsius, and that's because this was an LFP cell. On average, LFP cells tend to have higher temperatures required for thermal runaway than do NMC cells. NMC, the thermal runaway would happen earlier, around 210 degrees Celsius. That's a little counterintuitive that the higher temperature there is safer, but that's because you can heat it up more, it can take more abuse thermally and not go into this chain reaction if it's an LFP cell, whereas if that temperature is lower, it means that it's easier to set off the chain reaction. And not only is that temperature important for the fire starting, but if you think about it, the higher that temperature is, the more the cell can resist fire from a cell next to it. You can see that this temperature spiked up to 800 degrees C, so obviously the cells that are adjacent to that are also going to be heating up, meaning they could also be caught up in the chain reaction.